Welcome back to day 8. We're going to do 54, 55, and 56 in this video. 54 says to use syntactic division to divide x cubed minus 75x plus 250 by x minus 5. Well, again, I didn't teach you how to do syntactic division, so I'm going to show you this using long division. Now, x cubed, notice we're missing the x squared term. We have to put that in here when we do the long division. Then we key on the guy up front again, ask ourselves what times x gives me x cubed. That's x squared. Multiply it times everything on the outside. And then subtract. These cancel. 0 minus negative 5x squared makes positive 5x squared. Bring down the next term. Multiply what times x to get 5x squared? That's going to be 5x. Multiply that times everything on the outside. Get 5x squared minus 25x. And subtract. 5x squares cancel. Negative 75x minus negative 25x makes negative 50x. And bring down the next term. X times what gives me negative 50x? That's going to be negative 50. And negative 50 times x makes negative 50x. And negative 50 times 5 makes plus 250. And when we subtract that, we get 0 for a remainder. So x squared plus 5x minus 50 is our answer. And that is answer A. 55 tells us to use the remainder theorem and syntactic division to find the function value. Verify your answer using another method. We're asked to find f of 2 for f of x equals 2x cubed minus 6x plus 6. Well, the remainder theorem is great and all that, and it's lots of fun, but if we want to find f of 2, we're just going to plug in 2 for x. Especially on a multiple choice test. This is going to give me 2 times 8 minus 12 plus 6. This is going to be 16, and this is going to be negative 6, so the answer is going to be 10, and that's going to be answer B. 56 says given that negative 3i is a root, determine all other roots of f of x. Well, first we need to know that negative 3i can never come alone. If negative 3i is a root of the equation, then so is its conjugate, positive 3i. Complex roots never come alone with polynomials. This means that x minus negative 3i or x plus 3i is a factor, and this means that x minus 3i is a factor in this polynomial. If we multiply those together, we get x squared minus 3ix plus 3ix, and then minus 9i squared. Recall I squared is negative 1. The middle terms cancel, so this gives me x squared plus 9. If I divide this by x squared plus 9, and remember when I'm dividing, I need to make sure I put the missing terms in there, I can find the other factor. Ask myself what times x squared makes x cubed. Key on the guy up front again. And that's x. Multiply that times everything here. I get x squared, x cubed plus 0x squared plus 9x. And I subtract that. These cancel. Gives me 2x squared. These cancel, so plus 0x. And bring down the 18. Ask myself what times x squared makes 2x squared. That's going to be plus 2. And 2 times x squared, 2 times 0x, and 2 times 9. Those will all cancel. When I subtract, remainder is 0, so x plus 2 is my other factor. So negative 3i, positive 3i, and x plus 2, I set that equal to 0. And get x equals negative 2. So those are my zeros, and that looks like answer C. Thanks for watching on day 8.